In section 5.3, we're going to learn how to solve systems of linear equations by elimination. So what elimination means is that we're going to try to get rid of one of the variables. Get rid of one variable. So get rid of is just the sort of more casual way to say eliminate. So we're literally going to eliminate a variable. That's the goal. So let's see an example and see what this looks like. So suppose the sum of two numbers is 15. So right away, as I read through a word problem, I'm writing it down. It says the sum of two numbers. Hopefully remember from the very beginning of this term that sum means to add. So the two numbers I'm going to call x and y. So this says that x plus y and is means equals 15. All right. That's the first statement. Then it says their difference is 12. Difference means subtraction. So x minus y equals 12. So one way to figure this out would just be to guess and check, right? Try different values of x and y. That's not using algebra though. The whole point of this course is that we learn how to solve for variables. Another approach is to set up and solve a system of equations. So remember, when we set up a system, we're just joining these two equations that we got separately into one unit. And we usually use this curly bracket on the side to say that this is one system. We already know how to solve this by graphing and by substitution. But we want to learn a new way today, which is the elimination method. So let's rewrite this system because we're going to try to get rid of one of the variables. Substitution does that in a way, but elimination, what we do is we add or subtract. Usually we're going to focus on adding to eliminate a variable. All right, so let's try that. I have x plus y equals 15, x minus y equals 12. So instead of solving for one variable and plugging it in, that would be substitution, I'm going to add these equations together. By adding them together, x plus x makes 2x, but y plus a negative y makes a 0y. In other words, it goes away. And then we still have 15 plus 12 is 27. So if I add the left side, I have to add the right side. We still have to do the same thing to both sides of our equations. So I'm adding every single piece. Elimination only works is if when you add, you get one of the variables to go to 0. That's the whole idea. And we'll see some examples where we have to manipulate the system in order to get it to add to 0. But that's really our goal, is to get one of the variables to cancel or to go to 0. Because now what we have is 2x is 27, so I just divide both sides by 2. And half of 27 would be 13.5. Now, just like when we were solving with graphing or with substitution, we need to find the y that goes with that. So we would plug this into either one of our equations. I'm going to pick the one with the positive numbers, but really you could check it in both. That would be good to sort of make sure it's the same y value that you get. So let's plug it into the first equation. 13.5 plus y equals 15. So I subtract 13.5 from both sides. So it makes y being 1.5. So that tells us that the numbers are 13.5 and 1.5. And we could check in the second equation, right? I found y using the first equation, so the second equation is a good one to check in. So just to do a quick check, x minus y is 12, so that would be 13.5 minus 1.5 is 12. That totally checks out. Now I left all this space here because up here I said we could add or subtract to eliminate a variable. I want to show you that there was a whole different way we could have done this problem by eliminating the x's instead of the y's, because we always have that choice. And this one's set up so it's not too difficult to do it in that way. So I'm going to restart, and this time eliminate y. Or no, x, sorry, this time I eliminated y. I want to try with x. This time eliminate x. So let's start over. X plus y equals 15. X minus y equals 12. And this time, instead of adding the two equations, I want to subtract. And as long as I do it to both sides, I'm totally allowed to do whatever I want. So I want to subtract both sides. X minus x is 0 x's. Now, subtraction is a little trickier, which is why adding is definitely the default, because we have to subtract a negative. So y minus a negative y, x minus a negative ends up adding that y. So this ends up being 2y. So it's like y plus y is 2y. Remember, we're subtracting. 15 minus 12 is 3. So if I subtract over here, I have to subtract over here too. The x's were eliminated. That's why this is called the elimination method. So I just get 2y equals 3, divide both sides by 2, y equals 1.5. So that's the same answer. And I'm not, we could plug it back in and find x, but I just wanted to show us that you could find the same answer by eliminating either of the variables. There's not just one way to do it. So let's go through the steps, right? That after we do this, we would have to plug it in and all that. But let's talk about the steps in a more general sense, now that we've seen that it works with addition and subtraction. So first, this is one of the few times we like standard form. Standard form of a line is not y equals mx plus b. It's this one where x and y are on the same side, and we're setting it equal to some number. So just like what we started with, we had x and y on the same side equals a number. That's what we're looking for with standard form. Then, if necessary, we're going to multiply equations by non-zero numbers so that the sum of the x coefficients or the sum of the y coefficients is 0. That sounds convoluted, maybe not, maybe it's totally understandable to you. But we're just trying to get the coefficients to match. So get numbers to add to 0. That's the goal. So you could have 2x and then a negative 2x. That would add to 0. You could have negative 5y, positive 5y. That would add to 0. So we're trying to get the coefficients on either x or y, doesn't have to be both, one or the other to add to 0. So that ideally we want one positive, one negative. That way we don't have to mess with the subtraction. That way we can just add to get to 0. So we're going to add the equations. The sum will be an equation with now just one variable because we eliminated the other one. Eliminated the other variable. So it could be either x or y that's left. So now we solve for either that x or y. Back substitute it. Put it back into one of the original equations and then check in the other. I wouldn't say the both. I'm just going to say instead of both, the other original equation. Because we're going to find the eliminated variable with one equation and then the other equation is great for checking. Finally, I'm going to add, if it's a word problem, word problems should be answered in complete sentences. In complete sentences, like I did in the previous one. I said the numbers are, and then what the numbers are. If it's not a word problem, if it's a purely algebra problem, where it's just set up with x's and y's already, the answer will be a point. So the algebra problems, if they start the problem with x's and y's, it's answered with a point, x comma y.